Now I will discuss the super mesh technique. Already we have solved a problem by using the superposition theorem. Now I will show how could we solve the similar problem by using super mesh technique, and it will take very short time period. First, what is super mesh? Super mesh means the is a big loop or a big mesh. Okay, just consider this circuit. In this circuit, two current sources are available. So remember that whenever a circuit is having multiple current sources, at that time only you should apply the super mesh technique. Clear? Here multiple current sources are available, 1 ampere and 2 ampere. So that problem can be solved by using superposition theorem, but it will take huge time. So far you have seen that thing. Okay, as this type of problems are very frequently appearing in different types of competitive exams, that's why you should apply such a technique so that in a very short time period you can solve out this problem. That means you can save your time. That is my target. Okay, and where in which case you should apply the super mesh technique. Remember that whenever a circuit is having multiple current sources, at that time only you should apply the super mesh technique. Okay, and according to the super mesh technique, if any current source is common for two adjacent loops, just like this, say this current source is common for this loop and this loop. Clear? So at that time you should eliminate this current source from the circuit. Clear? Similarly, 2 ampere current source is common for this loop as well as this loop. So you can eliminate 2 ampere current source from the circuit. Okay, but you should consider the current effects. Once again I repeat, you can eliminate the common current sources, but before eliminating the common current sources, you should consider the effects of that currents. Clear? Let me explain this matter. First, just go through the circuit. I1 current is coming there, this node. I2 is coming, this node. So what is the total current flowing through this 1 ohm resistor? That is 3 ampere current. So you get the 3 ampere current here. Again, what is the current flowing through this? 3 ampere is coming from this side and I is coming from this side. So total current is 3 plus I ampere, which is flowing through this 1 ohm resistor. Clear? So same current is flowing through this also 1 ohm resistor. That is, what is the current? That is 3 plus I ampere. At this node 1 ampere is entering, so rest of the current will flow through this 1 ohm resistor. So what is the rest of the current? That is, 1 is entering, that is 2 plus I ampere. At this node 2 ampere is entering, so rest of the current is flowing through this. So 2 is entering, so I current is flowing and it comes back to its negative terminal of the battery source. That means I ampere is generated from the positive terminal of the battery source, and after traveling, same current is entering to its negative terminal. So I1, thus we have seen that I1 current which is generated from the positive terminal of the battery source after traveling through the entire network, this I ampere is coming back to the negative terminal of the battery source. Clear? Now we have considered the effects of the currents. Then you can eliminate this common voltage source, that is 2 ampere is common for this two loop, so it can be eliminated. Similarly 1 ampere is common for this and this loop, so 1 ampere can be eliminated. 1 ampere can be eliminated. Now this resistance, 1 ohm resistance, is open at this end. Okay, so there is no use of such kind of resistance in that particular circuit. Now you can eliminate this resistance also. So it is a huge loop that is known as super mesh or super loop. Number of loops are merged into a single big loop, just like your house structure. In that case, in case of our house building, we used to term it as structure, but in case of multi-storied building or a huge flyover, we will term them as superstructure. Similarly, in that particular case also, whenever number of small loops or small meshes are merged into a single big loop or big mesh, at that time we will consider this is a super mesh. Okay, and this is the technique. Now only single loop is available there, so comfortably you can apply the KVL for this circuit. So if you apply the KVL for this circuit, the sum of all the voltages in this particular loop equals to 0. So sum of all the voltages means 1 into this, that is the voltage drop. So this voltage drop across 1 ohm, same current is flowing also this 1 ohm resistance, that means 1 plus 1, that is 2. 2 into 3 plus I. This is the drop across these two individual sources, across these two individual resistors, then plus of this drop, that is 1 into 2 plus I, this drop, and then plus of minus 10 volt as current is entering through the negative terminal, that's why we should consider negative, equals to 0. So by solving this thing, we can get I equals to 0.666. Therefore, power P equals to VI, or equals to 10 into 0.666, that is 6.66, approximately 6.67 watt. Thus, result is same what we have derived in the by using the previous technique also. Okay, but this technique will take very short time periods. That is the advantage of using super mesh technique over the superposition.